Welcome back. I have a bolt here at point A. Also, I have a crescent wrench here with a lever arm that is 300 millimeters long from point A till point B. Then I also have another bar from point B till point C, and the distance between these 2 points is also 300 millimeters. And the second bar is at 30 degrees to this wrench. The applied force at point C is 200 newtons, and it's 15 degrees to the line that is perpendicular to the extension rod. Considering all this information in the image, first, what's the moment that is produced about bolt A due to this force? And then secondly, if you want this moment about point A to be 120 Newton meters clockwise, then what would be your required force for that? So in the second question, you have to replace 200 newtons with another force in order to get this moment. Try it out by yourself first, and then see the solutions in the next video. Thank you very much. Welcome back. So let's now find the moment about point A due to this force F equals 200 newtons. Here's how I did it. If you look at this image here, then we can construct a triangle between the points A, B, and C. These are these ones here, A, B, and C. Here you have 30 degrees, which means that this angle here, that's 150 degrees. It makes sense because if you add 150 to 30 degrees, then you will get 180 degrees. Then this side is 300 millimeters, and this side is 300 millimeters. And because of that these two sides are equal, you know that these two angles are also equal. This triangle essentially looks like this. This is 300, this is 300, this is 150 degrees, which is this one here. We can say that this side is L, so that means that this side is L, and so this angle must be equal to this angle here. And you can calculate it like this. 180 degrees, which is the sum of all the angles, minus 150 degrees, that will give you 30 degrees. That's the sum of these two angles. And now if you divide them by 2, because these two angles are equal, that means that this one is 15 degrees and this one is 15 degrees. And now in order to find this L, one option is to use the cosine rule. So L squared would be 300 squared plus 300 squared. These are these two sides here squared minus 2 times 300 times 300 times cosine and the angle between them, which is 150 degrees. And now I take the square root of it, and so L will be approximately 580 millimeters. So L equals 580 millimeters, and then I have 15 degrees here and 15 degrees here. And then I have this force F, which is 200 newtons. It's 15 degrees from the line that is perpendicular to this extension rod. However, now that I have my length from the bolt A till point C, what I really want to do, I want to decompose this vector in such a way that one component perpendicular to this line L, let's call it F perpendicular, and I want the other component to be parallel to this line L. Let it be F parallel. Now since you have 15 degrees between this extension rod and L, and this red line, it's perpendicular to this extension rod, and then F perpendicular is perpendicular to this L side. You can see that, for example, here, this line is 90 degrees to this line, and then you have 90 degrees between L and F perpendicular. Because of that, we know that this angle here, let's call it theta, it's also 15 degrees, which means that if this is your force, F equals 200 newtons, and this is one component, this is another component, the total angle here, it will be 30 degrees. It will be theta plus 15 degrees, or 15 degrees plus 15 degrees, 30 degrees. It means that F perpendicular equals F times cosine 30 degrees, or in other words, 200 times cosine 30 degrees newtons. Then L was 580 millimeters, or 0.58 meters, and thus the moment about point A equals minus F perpendicular times L, because that's what you want. You want F perpendicular to be at 90 degrees from this line that goes from point A till point C, from the place where you have the middle of your bolt till the place where that force is actually applied. So you will have minus 200 times cosine 30 degrees, which is the force perpendicular, times 0.58 meters. And if you calculate that, it will approximately be minus 100 Newton meters, or 100 Newton meters clockwise. And that's how you do it. And now in the second question, if I want MA to be 120 Newton meters, well, then I will say that my F will be my unknown, let it be X, and so I will have MA equals minus X times cosine 30 degrees times 0.58 meters. This here, that's my unknown F perpendicular, and so it has to equal minus 120 Newton meters. And so my F, which is my X, it equals minus 120 over minus cosine 30 degrees times 0.58, and that will approximately give you 239 newtons. And there you go. This is the answer for your second question. Thank you very much. Welcome back. I have a crane here that holds the load that is 120 kilograms. The angle theta between the crane and this horizontal line can vary between 0 and 90 degrees. In addition, the crane has an extension X. It can vary between 0 and 5 meters. We have a small pulley at point B, but we can neglect its size. And so you have all the dimensions in the image. And now my question to you is, what's the moment about point A, which is this one here, as a function of X and theta? So you have to construct a mathematical function where you have two independent variables, X and theta. And then once you have it, you can tell me at which X and at which theta your MA will have the maximum magnitude. So try it out by yourself first, and then see the solutions in the next video. Thank you very much. Welcome back. I have a crane here that holds the load that is 120 kilograms. The angle theta between the crane and this horizontal line can vary between 0 and 90 degrees. In addition, the crane has an extension X. It can vary between 0 and 5 meters. We have a small pulley at point B, but we can neglect its size. And so you have all the dimensions in the image. And now my question to you is, what's the moment about point A, which is this one here, as a function of x and theta? So you have to construct a mathematical function where you have two independent variables, x and theta. And then once you have it, you can tell me at which x and at which theta your MA will have the maximum magnitude. So try it out by yourself first, and then see the solutions in the next video. Thank you very much. Welcome back. So let's now find MA as a function of x and theta. I'm just going to draw a line from point A, which is this one here, until point B. The load here has 120 kilograms. Thus, the Fg, or the force of gravity, that this point B experiences is 120 G newtons. Since we neglect the size of the pulley here, we can say that this 120 G goes directly through this point B. Then the fixed part of the crane starting from point A, that's 9 meters minus 1.5 meters. That will give you 7.5 meters. And then x here is just a variable, just like theta. In order to calculate the moment about point A, only the component of the gravity force perpendicular to the crane needs to be considered. So let it be Fg perpendicular. And then the other component is parallel to the crane, and we don't consider that. You can see that since you have an angle theta here between this horizontal line and the crane, you will have the same angle here, theta. If theta here equals 0 degrees, then here as well, theta will be 0 degrees. Therefore, we can say that Fg perpendicular equals 120G times cosine theta. And now the moment about point A equals minus 120G times cosine theta times 7.5 plus x. It's negative because it's clockwise. This one is Fg perpendicular. This one, that's the total length from point A to point B. And there you go. This is your moment function as a function of theta and x. And now, MA has the maximum magnitude when theta equals 0 degrees and x equals 5 meters. Remember, theta could vary between 0 and 90 degrees, and x could vary between 0 and 5 meters. This cosine theta here, it can only vary between 0 and 1 because theta can only vary between 0 degrees and 90 degrees. When theta equals 0 degrees, then you have 1, and when theta equals 90 degrees, then you have 0 for your cosine theta. And so in order to increase the magnitude of your moment, your cosine theta should be 1. It should be the biggest number possible. And that happens when theta equals 0 degrees. And then you can obviously see that the greater your x value, the bigger the magnitude of your moment. Since your x maximum is 5 meters, the magnitude of MA will be maximum at x equals 5 meters. So in our case, when theta equals 0 degrees and x equals 5 meters, then you will have a maximum clockwise moment. Or if you don't care about the directions, then the magnitude of your moment will be maximum. Thank you very much.